So in this video we'll be going over the procedure for port expansion using our Modbus devices. And in this particular example we will be using one of the Modbus devices that are currently offered through our shop. That will be the WP8027 Atom. And that's one of the many devices that we offer depending on your needs. This one has 16 outputs, which you can use to expand your ports of your typical myCNC controller. So for example, an ET10 controller, like we'll be using here. And there are two main ways to work with Modbus devices using myCNC. So first of all, method one is to send commands directly from our PLC procedures. So that's a very hands-on process. You're writing out the commands by hand. And method two is to map or to display the I/O input-output ports of the Modbus onto the input or output ports of the controller. So within that reserved space for the controller, that will allow us to expand the ports. And that's a more simple method in the long run because you're not writing out every command, but at the same time you do have to set it first, so it might not actually be that apparent from the get-go. And to start off, we will always be using PLC commands to even initialize the Modbus device. And here, for example, I have the WP8027 Atom user manual, and that's a manual that you can find online. It features a number of commands. So, for example, there's communication parameters, command for digital output, several control, single control, with a couple of examples and a breakdown of what each part of the command represents. And in our case, to start off, we will be using two commands. So the command for the module address setting in section 5.5, and that will be writing a single register, the address 64 in hexadecimal system, to which we'll be sending a value for the address, which will be in the 01 FE range. So that's just a range within which we can specify some address. And the second command is in section 5.6. That's our bit rate, or our communication bit rate. Here you have some communication parameter, and we prefer to use communication parameter 9600. So effectively, the two things you'll be doing is you'll be specifying the address for the Modbus device that you're using, and you will be specifying the bit rate. So we'll be specifying the bit rate 9600 and 81. And we'll be doing that through the PLC commands. So as you can see on the main screen, I have an empty button that I have just created. The creation of that button is described in other manuals, or a button like that, but all that button does is it summons an empty macro M409 that I've also just added for the purposes of this example. And this will be the PLC procedure through which we will be sending some commands to the Modbus device, the WP 8027 Atom. And we'll be doing it by using the information that's present here in the PLC Modbus API manual, where you have some variable addresses and you have their descriptions. So here, what you will be using is the first four. To start off, you have your device ID. To change the device ID, then you select RTU for the Modbus mode. Afterwards, you select the bit rate and the communication parameters. So 60010, 60011, 12, and 13 are the four variable addresses that you will be using to start off. That is obviously not everything that you need to communicate with Modbus period, but that's a useful jump-off point for a user who is just trying to establish communication with the device. And here I will be pasting a sample code for this sample communication. So we set the Modbus RTU, we set the bitrate to 9600, we set the communication parameters to 8 and 1. Those are effectively some of our basics. And at this point, in order to actually start communicating with the device, to be able to send commands to the device, to receive some information maybe from the device, stuff like that, we'd like to set an address for the Modbus device, to which we'll be later referring to. And that is done through our variable address 60010, which is our set device ID, which you can see in this PLC code example right here that I have up on the screen. So we have this, and I'm just going to skip ahead while I'm writing out the code. So here I have written out a series of commands to first of all set the ID. We use 0 here because we're writing the ID right now. Then we have our value that we will be writing into address 64. So our value will be 10, that will be the new ID, and we're writing that into address 64 as per the manual. We press the button and we can see, or I can see rather, that the Modbus device has blinked green, so it's accepted this new address, or rather this new ID for the device. So at this point we have set the ID. Let's set the bitrate. We will be using the very same ID here that we've just set. So we've set an ID of 10. We'll be using that one more time, again because we'd like to refer to the Modbus device that we're using. And next we're writing a value, so we're writing the bitrate value. And for bitrate, we'll be using 9600, and that's we're writing to address 65, and that value will be 2, again as per the manual. 9600 refers to value 2, and we're writing that into address 65. We reflash, we save and reflash, we press the button, and I can see that the device is blinked green now for a little bit longer because it received 2 commands, first for the ID and then for the bitrate. Now at this point we can go through some more complex tasks for our commands. And first of all, we would like to maybe write to the digital outputs that are present on this Modbus device. Again, we're using the device with 16 outputs. And we can either use the digital output several controls, or we can use the digital output single control. So you're you're sending a command to some coil address, you're writing either multiple coils, or you're writing one coil each time. Here you are going to be using some coil address that you're referring to, just the physical address of the coil that you would like to effectively either turn on or off. And again, you will be using the PLC commands to manipulate this. So again, we have set the ID, we've set the bitrate. We don't really need those anymore, so I'm going to be commenting those out. And now we would like to maybe turn some outputs on, or if they were on, maybe would like to turn them off, depending on our application. And here, again, we're using the same ID. We're writing a value, so 0xFFFF. We're just going to be turning all of the outputs on. We're writing a single register 60035. So 60035 is write multiple coils as per our PLC Modbus API. And we'll be writing some value. So currently we have the 0x65, but it's going to be a little more complex than that. And I'm going to be using a variable called a here. So just so that we know what we're referring to. So again, we have our ID, so the ID of the device, of the physical device that we're writing to. We have the value that we're writing, so those will be all of our outputs. And then we would like to specify which exact coils we're using. So we will turn on all the LEDs. So it's 16-bit, move it by 24. And then since we are using all of them, we only have 16 outputs. That's just going to be +0. And again, this should this a variable or value should be put for the write multiple coils variable address. Those are our output values. So again, we double check, write multiple coils, that's correct, save all, build all, and send. We go back to the main screen, I press the button, and I can now see that all of the LEDs are currently on. And maybe at this point we would like to turn all of them off, and we're just going to say we're setting a value of 0 for all of them. And I go press the button, and now all of them turn off, because the value that we're writing to them is 0. Okay, so that example is complete. And maybe now we'd like to move on to a more complex example of some sort of a cycle. So, and in order to do this loop, we will write an if-else statement, which will effectively every 256 milliseconds, it will turn some LEDs on and off, just in a continuous cycle. We'll be shifting or moving the timer by 8, so only 8 LEDs will be turning on and off, and we'll write a condition in which if the condition is met, those LEDs will turn on. If it's not met, they will turn off, so 0xFF for on, and then 0x0 in hexadecimal is for off. And we're writing this 1 or 0 value into these coils, into these multiple coils. So it's important to remember that these are multiple coils that will all be doing the same thing by using the 60035 command, or the variable address rather. And again, all this will be doing is creating an infinite cycle. We'll try to save. We realize we didn't actually specify the while condition. Again, since it's an infinite cycle, it's just while 1. Just going to run continuously, and seems we've forgotten a curly brace as well. We add that, and it should let us save right now. Okay, perfect. We have saved. We go press the button, and I can see that about twice per second, 2 times per second, the 8 LEDs blink on and off, on and off. And again, perhaps now we'd like to change this up a little bit, we'd like to play around with it, and we would like to say that maybe we would like to have the first group turn on, then the second group turn on. So now we save, we go to the main screen, click the button, that sends the macro, and we can see that now the first and the second group turn on and off intermittently. Okay, so that's about it for writing multiple coils by using a PLC command. So at this point we wrote multiple coils. Now let's try writing a single coil. So now we're only interested in one single port effectively. And this is going to be very similar to our multiple coils example, in that we will set some sort of a timer. So we're doing this in a while loop, in a repeated loop. And instead of 60035, we'll be using 60038 to write a single coil, which will request the 16-bit address of the coil and the value to write. So we're just going to be commenting out our multiple coils code right here, and we'll just be adding our single coil code. Alright, and at this point, this is actually a little bit simpler than the multiple coils example, since for our coil we are only interested in one port, let's say port 10 in our example. It can be any port, but just for the purposes of this exercise, let's use port 10. It's going to be the same timer system, and we will be writing, we'll be turning it on and off. And let's consult the manual, what the manual says. It recommends using, let me just find this out. Right, so it says FF00 for coil open and 0000 for coil close. So those are the two options that we have, on or off, for port 10. Now we double check this, save all, build all, and send. We reflash the PLC and press the button now. And I can see that, very similar to our multiple coils, now our port number 11, our exit 11, it's blinking twice per second. And it's port 11 because in the hardware, the ports are numbered from starting from 1. In the software, evidently, they're numbered from 0. And that's just a little bit of a mismatch of, you know, how you'd like to number your ports, how you'd like to view them. But effectively, our port 10, if you're numbering them from 0, or 11 if you're numbering them from 1, is now blinking continuously. So an important thing to note here is that when using this Modbus device port expansion procedure, for example through the PLC commands as just described, you must turn off one particular setting within the myCNC settings. That's located in Technology, Mill, Lathe, Spindle, and that's this RS485 Modbus communication for the Spindle. And the reason for that, despite it maybe seeming counterintuitive, is that it will be sending some registers for things like spindle speed control. So effectively you're going to be trying to communicate through a PLC procedure, but at the same time you will be, or the software will be trying to send information for the spindle. And those two will be conflicting. It's not going to let you actually communicate properly. So just disable that, save, and you should be good. So at this point we can map the inputs and outputs, so in our case outputs, of the Modbus device onto the outputs of the controller using the I/O expand cards mapping. And again, this is a much simpler method than using PLC procedures, but it does have its drawbacks. So for the mapping device, we'll be using the Modbus coil output expansion mapping device because we are using the WP8027 Atom Modbus device, which has 16 outputs. So the outputs are what we're going to be expanding. Next, we set the device ID. We know that we have previously, in the previous example, set our device ID to be 10 in hexadecimal. That's the same as 16 in decimal, so that will be our device ID. And next, we have our source port and our destination port. So our source port is our source from the controller, and our destination port is our destination on the Modbus device. And the source port, that is grouped in 8-bit groups, and destination port is grouped in 1-bit groups, effectively. So for the source port, for outputs 0 to 7, that's source port 0. For output ports 8 to 15, that's source port 1, 16 to 23, source port 2, and so on and so on. So again, it's 8-bit groups. I'm using an ET7 here in this example, so that has 16 outputs already on the controller, 16 physical outputs, so from 0 to 15. So ports 0 and 1 are taken up. But from port 2, 3, 4, etc., those are empty and those can be mapped too. So our output 16 to 23, our source port 2 will be the one that we use. Next, we select the destination port, and the destination port is in 1-bit groups, effectively, not 8-bit groups, and that's our destination port on the Modbus device. So that's the port that we'll be starting with. And again, since we'd just like to map 16 outputs, we select the destination port 0, we press the save button, and immediately, as soon as I've pressed the save button, I can see that the device has blinked green, meaning it has successfully received this new command. Okay, so at this point we have expanded some outputs, but the issue is that we have not actually expanded all of them. So let's go check which ones we have expanded. So we're expecting this 16 to 23 group, this 8-bit group, to be now mapped to. I'm going to be pressing these outputs and I'm going to be seeing if something changes on the Modbus device. So the output 1, output 2, output 3, etc. on the Modbus device are now blinking green. They're turning on. If we go through all of them just to double check, I can see that the first 8 ports on the Modbus device can now be worked with. However, we still have 8 more ports available on the Modbus device, so we'll be adding another option here, which is going to be very similar. So it's the Modbus coil output expansion, same device ID, since it's the same device we're mapping to, and our source port at this point will be 3. So we'll be mapping controller outputs 24 to 31. Again, this is in 8-bit groups. And for destination port, we'll be putting 8 because it's in 1-bit groups. So from port 8 to 16 on the Modbus device is what we'd like to be using. So at this point, with these 2 mapping devices added, we should be utilizing the full 16 outputs on the 8027 Atom. And if I go to diagnostics and I turn those things on, I can see that those are indeed turning on the Modbus device. So that's how you effectively expand the Modbus device through I/O cards mapping. So at this point, once we have mapped the Modbus outputs onto the controller space, we can treat them as we would treat regular output ports. So at this point, those are simply, for all intents and purposes for the software, those are simply additional output ports, and you don't have to do things like write single coils, etc. And we can use the simple port set and port clear commands, same as we would with any other output ports. I'm just going to be commenting out our previous code to have some sort of a timed blink, and adding a port set and port clear command to turn output port 23 on and off. I go back, I press the button, and what I can see now is that this port is again going to be blinking. But here comes the issue with this sort of an implementation. It's a little bit less precise than your typical, very hands-on method of writing to software. So previously would have a very even, very steady 2 times per second, or roughly 2 times per second blink. But right now it blinks a little bit unevenly, and sometimes it misses a pulse. So you should be using this for less critical applications, for less precise applications. Okay, so at this point, just to recap, you will be mapping to those ports, and you can be using them as regular output ports with port set, port clear commands. But the idea is that you were still using the device ID, and you are still using things like the bitrate. So you still have to write a very simple PLC command at the very beginning, even to do this very regular, very simple Modbus coil output expansion. You don't have to write the physical, write single coil, write multiple coils commands, but you should still be sending the Modbus device ID and device bitrate, things like that, to just initialize the device. And that's only done the one time. You aren't going to be doing this over and over again, but it's still necessary. So I'm just going to be deleting all this timer blinking code that we have going on right now, because we don't really need that. But what we do need, however, is these blocks of code that are very general, and that you will always, again, despite perhaps using the I/O expand cards mapping option, you will still always need to run this, you will still always need to send this through. So you will set the Modbus to RTU, set the bitrate, and set the communication parameters. That's the first block. That's for your myCNC controller. That will set those parameters inside the controller so it knows what it's communicating with. And next, you will be setting the ID and the bitrate for the Modbus device. So again, this is twofold. You are setting parameters within the controller, and now you're setting the parameters within the Modbus device. And once you have that finished, save all, build all, and send, you should be done with your Modbus port expansion setup.